Inputs and outputs. Alright, as you're working on graphs, you may have to do some reverse thinking. You might be given a graph and then asked to find certain outputs for a given input. So I've created a graph here. You don't have it on your paper, but you can just watch and take some notes if you'd like. If you want, you can stop the video and copy the graph down, but this is a pretty easy concept. So I want to use this graph that I created to find f of -2 and f of 3. Now remember, f of -2, this is an input. And in our coordinate pairs, x, y, the input is always the x value, and the output is always the y value. So if I'm asked to find f of -2, which is an input, all I'm doing is finding the coordinate pair where the x value is -2, and I'm going to tell you what the output there is. So I go to my graph and I find an input of -2. So I'm looking for the coordinate pair that starts with -2 in the x spot. And do we have one? Let's take a look and see. Here we got -4 for the input. Here's -2 for the input. What's the output? Well, in this case, it also happens to be -2 by coincidence. So if I want to find f of -2, what does the function give me for an input of -2? It gives me an output of -2 also. The twin coordinates there. Alright, let's also find f of 3. Now, I don't think I have an input of 3 listed. Here's the x, here's the x, here's an x, and here is an x, and none of them are 3's. But I know that I want to find the place on this function where the input is 3. So what I can do instead is I can go to the x-axis and count over 1, 2, 3, and then follow my pencil up that grid line till it bumps into my graph on that third grid line over from the y-axis, and I can guesstimate my output. And in this case, it looks like it's almost 4. So I could say for the input 3, I've got approximately an output of 4. So going back to here, f of -3, I'm going to use a wavy equal sign. That means approximately, because I'm kind of guessing here, is about 4. Now you try one more. Would you find f of 4? Find f of 4. Tell me what the output is when x is 4. Alright, did you say f of 4 is 8? Were you looking at this coordinate pair here to see for the input 4, I have an output 8. This is very easy. When you find it on your homework, you shouldn't have any trouble at all with it. Just a couple more items about graphing functions. We've talked about linear functions. Those are any equations like some of those that we've graphed already when we were finding intercepts. Back here in this lesson, this was a linear function. This was a linear function. They are functions that make straight lines. There are many other types of functions, and we're for now just going to call them nonlinear functions. The graph of a linear function does make a straight line. The graph of a nonlinear function is usually a curve, but we can also have scatter plots and other types of combined linear functions. So when you're graphing a linear function, we want you to find at least 3 points on that graph. And when you're graphing nonlinear functions, we're going to shoot for at least 5 points. And we'll have more examples of that later.